Hello, my name is Yongqi. I conducted my PhD research at the Delft University of Technology under the supervision of Professor Ram and Professor Hanivara. My thesis titled Safe, Efficient, and Socially Compliant Automated Driving in Mixed Traffic, Sensing, Anomaly Detection, Planning and Control. It spans the automated driving pipeline from robust perception to self-aware decision-making. Automated vehicles will not replace human-driven vehicles overnight. For many years, we will see others in roads. This creates two challenges. Firstly, automated vehicles must perceive complex driving scenes, for example, degraded landmarkings. Secondly, they must interact socially with humans whose behavior is uncertain and might be abnormal. My thesis tries to tackle these problems through three capabilities: seeing the road, detecting anomalies, and playing socially. For sensing and perception, I choose lane detection as a case study because it supports localization and lane keeping. Instead of relying on one single image, I use consecutive frames. I developed two hybrid spatial temporal neural networks with customized attention mechanisms and one pretraining method using masked secret autoencoders. The intuition is straightforward. If the current frame is settled, previous frames may still perceive useful information. As the video illustrates, the proposed models perform reliable in both normal and challenging driving scenes. For anomaly detection, automated vehicles must also recognize when something is unusual or unsafe. I investigated two cases: anomalous random images in digital maps and abnormal driving behavior in naturalist driving data. For the latter, abnormal driving behavior detection, I developed a semi-supervised hierarchical extreme learning machine enhanced with surrogate manner of safety, particularly two-dimensional time to collision. This approach identifies risky patterns such as abrupt braking and rapid lane changes, while reducing reliance on fully labeled data. The final step is planning and control. In mixed traffic, being safe is not enough. AVs must behave also understandable to human drivers. I proposed the framework for socially compliant driving, then studied roundabout driving as a case study. The proposed method integrates three complementary components: driving risk fields models the perceived risk imposed on surrounding human-driven vehicles. Model predictive contouring control together with a comparator defines the objective of ego automated vehicles. Finally, social orientation enables the vehicle to balance its own benefits against the welfare of surrounding human-driven vehicles. Overall, this is present an integrated approach to automate driving in mixed traffic. Thank you.